Hello everyone, I'm Nick, and today I'm going to talk to you about this library that is DrawnUI for .NET MAUI. Where inside its repository with some basic information about how to use it, about some enhanced information regarding its demo apps and sample apps to browse. So the entry level is not very easy right now because the documentation and enhanced one is unfortunately missing today. It's to be done, so you will have just sneak peeks from me, and you could browse demo apps. And today we will create some simple controls to demonstrate the use of this library. So why even care about this one? What's new? How can it be useful? Okay, let's open an app on an Android device. It's a rather complex UI we have here that I was passed from my client in Figma. So what I want to talk about here is the number of handlers you would usually have for every native view that would used if we were to create to recreate this design using usual MAUI techniques. Also, I have met a case when I just started this app that the native grid were recalculating every time some data information, some levels were updating its text inside. That was unacceptable because that were logging, unfortunately. So actually what we have here, we have canvases here for the connection bar. We have a canvas here for that information. We have canvas here for that grid with a drone scroll inside. Inside settings, that's the same story. You have just two canvases. This is one canvas and this is another one for navigation bar. We're avoiding here that lag that would appear if we would have upon opening or to create native views for every line we see here, for every label, for every small custom control. While those are virtual at the moment, and this is relatively fast to create because virtual controls are just, I don't know, chunks of codes in memory. Those are operations, those are commands for the rendering engine to draw them later. This app is actually in the demonstration mode, so we don't have to connect to a real Bluetooth device like it normally should. So we could see how it works in general, just to demonstrate how it works in a light that all of this is updated via bindings. This is not code behind, this is XAML, and these are just bindings updated while the app works. And at the same time, we know that this is a SkiaSharp canvas. This is SkiaSharp canvas 2. And the interest here for all of us is just those canvases, they support exact gestures and they support animations. So we have that freedom of using drawn canvas in a relatively easy way without worrying about, oh my god, how do I detect that click on a single text here or somewhere else. Now we're gonna back to the repository to see some examples, some other examples, just to see where it goes in regards of the limits. Maybe one of the latest examples that I have put online is that shaders carousel demo. Will not launch it right now because the video is here. Basically what we see here is just this is a single canvas, hardware accelerated one, of course, with a Skia carousel that is subclassed, and it's using what I called state aware effect that is applying shaders while the Skia Carousel changes its slides, changes its current selected index. Those controls are already drawn on that canvas. Those are virtual. Again, here we have just one, not thinking about something else, just one native view, just one handler created for this view. So another typical usage of the library is to create a drawn alternative for a collection view or for a list view inside your app. These cells are using image double buffer type of cache, means once the old cache is ready and the new one is not ready yet, only the old cache is drawn and new cells are rendered in background preparing the new cache, so you don't experience the lag on UI thread when new cells are created or drawn. I think this is really interesting and this is a really good use case. Other stuff here is, well, carousel, I'm not even speaking about it anymore because it's you have seen it already in the Skia Carousel shaders example. This is just a simple custom control created inside this demo app. It's not shipped with the library, just to demonstrate how you can create your own controls. You can create your custom navigation effects, and some of them are provided with SkiaShell. SkiaShell also have toasts provided out of the box. And needless to say, I have already mentioned that Skia Markdown label draws everything you want with Unicode characters and supports languages like Arabic. Now, I have launched this sandbox app that you have in this repository. There are several interesting examples there, like, for example, that game example that catches even keyboard events. I think to note on my catalyst, it would capture keyboard events inside the appropriate dedicated game demo project. There is a difference in the implementation between the sandbox app that is more to demonstrate inside a standard MAUI app and the dedicated DrawnUI app that is totally capturing keyboard and stuff while taking total control and is using its internal own drawn Skia shell. Here we're using standard MAUI shell. We can see that here we're consuming MAUI graphics. Hello, Javier. Awesome, aloha kit. As this demo just reuses its code. How to use existing MAUI graphics code inside a usual DrawnUI app. Well, not usual, maybe sometimes. It's very easy. We will open the appropriate page, MAUI graphics. We see that we have a lightweight wrapper that basically just provides the drawing canvas to the existing code. And your existing code might look like this. You might recognize this interface iDrawable. And the code is, for me, it's a bit not obvious because you have to draw lines, draw circles, etc. This library was born from this fact that it was a bit complicated to construct the UI from in my head. We will use more high-level shapes what I propose, we just directly go to the shapes page. So drawn shapes are presented here by the SkiaSharp control. It can have different types. There is a default type rectangle, then there is circle, ellipse, polygon, line. I might have forgotten something. Anyway, we will try to modify it using hot reload. Main page shapes, here it is. Okay, the interesting thing here, please kind of look at the map route here. This is a simple Skia line. It was constructed with 4 points. In XAML you can indicate points like this directly. Sometimes you might use a different concept of indicating them with the type converter. So you can also assign points like this, and the type converter will convert them to the array you already saw below. We have an interesting smooth points property. I will set it to 0. Please kind of look here. I'm clicking save, and you will see the original line, how it should be drawn. The smooth just lets us create something more drawn-like, for example, when drawing a path on the map. Anyway, we will remove this because we would want just draw a simple line for you to reuse in your usual designs. The vertical position would be just in the middle, and the X from 0 to 1, 0, 1. Okay, because this is not 1. And you see that we're using stroke path here. Also, I think we need a hit request. In your real world app, you would set hit request to 1. Knowing that stroke width is bigger than hit request, we are obtaining this effect. If you have a stroke width of 1, you would have a hit request of 1 and you're good to go. But I will keep it to 3 because it's more visible on the screen. We're still looking here at this line. When we remove the stroke path, you get the usual line that you could use in your applications. It's a lightweight virtual control, no handlers, no native views. You just draw your line with points. Okay, and just before we jump to the creation of something, let's see something fun here. Shadow ripples, an image inside a scroll view that is capturing gestures, passing them to a shader, and drawing infinite ripples with reflection, just to demonstrate what we can do on a single canvas. Okay, now to be quick, let's stop it. We will use an existing page that is called I created it, main page code for video. It contains just one canvas, and we will set it as a default startup page inside shell. The name, copy, paste. Okay, good to go. So we will launch it. A quick reminder, if that would be your custom control, you would subclass canvas, call it, I don't know, my awesome button, inside of it you would have your static bindable properties of this awesome button, excuse me, and you could have your additional logic, but actually we're just creating a UI for it just to demonstrate how it can be done. Usually I'm designing in XAML, but here for you I will design in code behind to avoid that part of the community. Well, that's the opposite, to meet that part of the community that just always designs their UI in code behind. Okay, so this canvas must capture gestures. So obviously gestures equal something. If we set lock, this canvas would capture gestures and will avoid passing them behind to MAUI controls like scroll view. This is important for controls like slider, for example, when you want to slide, and the scroll view might, with its own pen, especially on iOS, break your control behavior. You would use lock here. But we can just use enabled, means our gestures still will be passed to other parent controls in MAUI, but we will get our gestures. Well, we're just fine with that. Canvas has its content property, not children but content, because content is designed to have just one view for optimization purposes. So content will contain a wrapper, new Skia layout, and Skia layout has children. Skia layout, okay, children equal new list of Skia controls, and inside we have only one child. That is gonna be our Skia shape. We just saw it. Skia shape, all like the canvas, has content property, single child. We'll have a new Skia layout inside. Why? Because we want a horizontal stack there for our image and our text. So content will be Skia layout of type row. We'll have two children. First one will be suspense Skia SVG. I prefer SVG over images, but you can have an image here. Why not? And new Skia label. Okay, so regarding Skia SVG, we have several methods of setting its content. For example, in code behind, we can set the source. The source would reside in your resources row. Let's show it. Would reside here normally. Resources row directory. So if we were to use a source locally shipped, I would put it inside SVG, and I would type here source equal svg/.netbot svg. But we will put SVG in line to be a bit hard mode. SVG string equal like this. Tint color is white. Come on. And regarding SkiaSVG, I'll go to a site like svgrepo.com. I already downloaded this icon. This is a simple text. You can open it inside a text editor. You copy, and you just paste it here. Okay. I think it's time to save to maybe already save our app to see what we have achieved. I will just add a background color to our shape. To instantly see what we're working on. And then we will shape it more using hot reload, of course. Okay, so while it's compiling, we can already add something else. Okay, text equal placeholder. So what happened here? What happened is that scale label size was 0, SVG size was 0 as well, because it doesn't care about what text you have here. You have to indicate the size you want to use. So we will ask for a width request of, let's say, 20. And as I'm lazy, put log ratio to 1 means then I can change it here to 21 and the height will be also 21. Scale label is smaller in height than SVG, so vertical options is gonna be, you might guess, center. I clicked save. We will see what we have then. Okay, this is something. Skia shape. We see no shape here yet. The default type is rectangle with corner radius of 0, and also it is not stroked at all. So we would fix that. First of all, what I propose, we will add margin. Let's say 10, I don't know. Stroke color is black. Stroke width 1. Corner radius, I don't know, 16. Save. Okay, padding is missing, obviously. Yes, thickness horizontally more than vertically. Thank you. Then I think if this is a button, maybe it should have some fixed width, minimum 1. So we'll take this. What I propose that this shape would have a minimum width request of 200. And the layout inside would be centered. All right. Okay, thank you. Text color obviously must match. Okay. Almost there. Changing icon to be smaller. And maybe spacing between them needs to be adjusted too. As you see it, we're still using very familiar MAUI techniques to lay out stuff. The font is the one provided by the operating system here. It will be different on Android and iOS, so you might want to ship a specific font. It will be reused on all platforms. The look will be the same, and especially if it's from Google or whatever, normally not standard fonts, but nicely shaped fonts, they align vertically well, because here I see that the alignment, I'm sure, will be on Android will be different from the one on iOS, from Windows, and those all will be different fonts. So just for this demo, we will adjust a bit. We will let the margin, bottom margin here, just to align text for it to be nicer. But normally you would want to use a specific font that you would ship with your app. Maybe even we need more. Okay, what I will do, I will just add a translation here. And just forget about it. Okay, now we need to add gestures. We have already enabled them here. We have a Fluent extension that we could add to our shape that would be topped. We'll close this is shape. Okay, so with what? Not with, but with. Thank you. With control, and do something with it. C is our control. So SkiaShape C. We have a delegate to be used. Gestures on gestures. Here it is. Maybe some IntelliSense help. Yes, thank you. I like it to be like this. And, so this delegate, it must return the control that, the control that consumed the gesture. So I still fail to understand what is wrong with oh, okay, still this. Okay, sorry. So now this is very easy. If args type equal tapped, return us, and so indicate we consumed this, do not pass it somewhere, and to other drawn controls, and do something. What can we do? I propose we just simulate that counter we had in usual MAUI examples. So we need a field for this, and counter. And also, I think we need a reference to our label to be able to change its text. We will not use bindings right now. As we're in code behind, we will change everything from code behind. So this is our label. We will add same with extension to assign a skill label field label. So here with same and label equal me. Okay. Now here we can change its text. Equal my counter incremented top times saving checking. I don't like this translation. Save again. Top. Thank you. This is working. Now, this is too much primitive. We will add some shadows, I think, to be able then to simulate a pressed effect. Let's add some shadows for the SkiaShape here. I think we will add them like this. shadows, add, thank you, new one, which will be colors black. That blur would be of 2 to be more precise, not too much smooth, and offsets 2. Okay, is it visible enough? I don't know, it's okay for now. Okay, now I want all this to be animated when I click on it. We will change shadows, I think, and we will change the translation of the shape. So here, inside of this already existing delegate, we will add something similar, like if we have the down, and if we have the up. So when it's up, you don't have to return, because you might want the up to be passed to other controls that might change their state to the usual one after they maybe were pressed, and then they were pressed, and then they maybe passed the gesture to your control. Okay, for the down code, we will translate the control down. Translation x1, translation y1, 2. We need to affect shadows, I think. So shadow will have its offset set to 0. And we already see what is need to be done for the up event. We need to restore this. We should think later on refactoring this to create sub-methods for initial state and press state and call them. But right now we're just progressing logic. Okay. So let's click. We see that. I hope you see it. It's animating fine. Also, just for the last fun of it, see, background color is, let's say it's gonna be something more. No idea, it's not very important. SkiaSharp. Had its color, had its initial color set to what? Colored blue. Okay, down, up. And I think that would be our last touch. Okay, so you see that this is all drawn on a canvas. What would normally also be done is that you would remove this. The canvas would adapt to your button size. This is the first step. Also, you would maybe cache something for the button to be redrawn only when really necessary, when the text changes. So you would, this scale layout that is a wrapper, you would use cache, I think. I would go for image, why not? You could use operations too. You could read more about cache inside the README file, but like this. So this is our control. We have reserved space for shadows. This is obligatory. So your canvas will be always bigger than the real drawing area. In MAUI, you can place in your control readme that it can be easily fixed with negative margins. You can place negative margins to your control, and it will be drawn like if it had this size. Okay, another maybe interesting thing is this demo app that you might see in the repository in form of video running on Android device, and I would show you this. Hello. Camera running with effects with decent FPS, I think. This is just a debug version, so expect 60. And we're getting data in real time from camera, and we're running on a single canvas. Again, I invite you to visit the DrawnUI.NET MAUI repository, maybe put a start to it if you find it interesting, and maybe collaborate on it. I would be more than happy if you provide your own effects, if you provide your own animations or fix something. I mean, also, if you have some use cases, would be also glad to share them inside the repository, and maybe we could make a video together showcasing your custom controls created with this library. Well, I just hope this was a bit useful for you, and I see you in Twitter and somewhere else. See you guys. Bye bye.